Okay, the walking water video we watched was pretty cool, but it's no magic trick. What we saw was actually something called capillary action. And what capillary action means is the ability of water to move in the spaces of porous material. So there's a few things we need to talk about to understand capillary action. So right here in the definition, we see this word porous material. Porous material means something that has holes that water can get inside of and fill those spaces. Rocks can be porous. If you look here, there's lots of holes. This actually is something from my shower. You can see there's still water in it. Water will get in there and fill those holes. This is a porous material. If you think about a glass, however, it's very flat and smooth. That's a non-porous material. There's no spaces in here for the water to fill. So the water is able to get inside of those spaces. And the reason why that works is because water has some pretty special properties. Do you remember our water molecule? So, although this is obviously not what water looks like in real life, this is a big representation of what the water molecules look like. This is the oxygen, and there's two hydrogen atoms attached to a single water molecule. So, the reason water is able to stick together and travel inside of those porous spaces is because it actually has a magnetic charge. So, part of the water molecule is negatively charged and part of the water molecule is positively charged. And so, if you've ever played with magnets, you know that means that they want to stick together. So, when you have two or more water molecules, they will actually be drawn together because of their magnetic properties. In science, we call it polarity. We'll talk about that in the next couple lessons. Water, when it's together, always sticks together. So when water is inside of a porous material, it's going to do two things. It's going to stick to other water molecules, and then these sides also have magnetic charges, like these ones here. These sides are also looking for other things that they can reach out and cling to, such as a paper towel, which is what we saw in the walking water video. The water molecules are also attracted to the empty spaces inside of a paper towel. If you felt a paper towel, you can see that it's rough. There's spaces in there for the water to fill. So the water is sticking together and it's also sticking to the porous material and traveling that way. We've actually already learned about capillary action. I just didn't tell you that. Capillary action is the same thing that plants use to get water from their roots up into the rest of the plant. The roots of a plant are porous, just like the rock I showed you, and just like the way a paper towel is. Inside of the plant roots, there's little holes and openings, and the water that's inside of the ground is able to stick with the water and to the roots, and it travels up the roots and into the rest of the plants. So, although it might seem like magic, we really just have capillary action.